And we're on. Good evening, everybody. Welcome. Hello. We just had a show of hands for who is a student. It's probably easier for me to know who is not a student at the University of Law. Oh, actually quite a few of you, more than I thought. But welcome, one and all. This is one of the biggest sessions we've ever had. Very exciting, fresh start, lots of new people. I'm really excited about it. This is quite a big room, quite a big group. I don't have any amplification, so I will try and project, but if you can't hear me very well, there are a few spare seats at the front. If you're like me and your ears don't work very well, so please feel free, don't be shy. So Tom's already talked a little bit about this, but these sessions, this is an introduction to C++. So as Tom mentioned, it's a mixture of talks, class exercises that we'll do sort of in here, and homework that I'm going to give you to practice by yourself. So we can't turn you into an expert, into a C++ expert in 2 hours a week, sadly. Okay, so learning a programming language, it's a lot like learning a musical instrument, right? You can have lessons. And lessons are very useful, and lessons will help. But lessons aren't how you get good at playing a musical instrument. You get good at playing a musical instrument through hours and hours of practice. And programming is like that. So we have these classes, and just like music lessons, we can show you the right techniques, we can suggest things that you should practice, but the way to get better is by putting in the hours yourself. Okay, so I guess what I'm trying to say is, you need to be prepared to do quite a lot of work away from these classes as well. And part of that is, as Tom was saying, these sessions we have on a Thursday evening. So the idea is we get a group of people, hopefully a lot of you, can join us. And it's not a formal session like this. There's not somebody standing at the front talking, presenting slides or anything like that. It's a lot more informal. But it's a place for people to come and to really work on their programming practice together. And we always have an experienced developer, usually Ollie, who is sadly not here tonight. Oh, okay. Just come back from his holiday, so we'll let him off. Usually Ollie is there on a Thursday night, and he's been doing this for years and years, and can help you out with any problems. So I really, really highly recommend everybody come along on the Thursday as well, because that's really how you improve. So we can't turn you into an expert, but we will try and give you enough information to get started, to push you into the right direction, to show you the right techniques, to help you learn for yourself. So some of you may have seen this cartoon. It's a bit small on the screen, but you can look at it later. It's how to learn C++ in 21 days. And if you can't read it, it's basically saying the only way you can possibly learn C++ in 21 days is by spending about 14,000 days inventing a time machine and then going back in time to 21 days since you started. And what this is trying to say is, this is a commitment. This is not something that, unfortunately, it's not something you can just have 2 hours a week and in 6 months' time you'll be an expert. It doesn't work like that. So modules. So Tom already mentioned this, but our program, our course, what we do, we have divided up our curriculum into various modules. So each module, roughly 4 to 8 weeks, depending on the topic. And we have tutorials and practice. And then we have this sort of little multiple choice quiz exam. Don't want to call it an exam. Quiz, questionnaire. Let's call it a questionnaire. We have a questionnaire at the end so that you can gauge what you got out of that, and we can gauge what you got out of it and sort of work out what level people are and help us tailor the next module appropriately. So this module is initial C++, and no prior C++ knowledge is assumed, which I guess is probably right. But actually, I'm just out of curiosity, is there anybody who has done any C++ before? Well, you two, yeah. Okay, a few of you. Who's done any sort of programming before? About half, good. And who has just, never written a computer program in their life and has no idea where to begin? Okay, so you've dived into the deep end. So, well done. We'll see. We'll do our best to get you guys programming before you know it. So yeah, no prior C++ knowledge is assumed. I'll be honest, you are going to have an easier time with things if you have had some programming experience. If you already know about what functions and variables and stuff are, that's just going to give you an easier starting off point. A little less that you have to take on board in the first few weeks. But if you've never done this before, hopefully it'll still become clear in time. Feedback. So we like to hear from you. We love hearing from you. We love knowing what we do well, and actually probably more importantly, what we don't do so well. What you'd like to know, what you think works, what doesn't work. And you can do that if you want to do it sort of privately, then you can email us. The address is on the website, to admin@cpplondonuni.com. That'll go to me, to Ollie there in the hat, to Tom. We're the organisers. But what we really encourage everyone to do is to join our Slack channel. So for those who don't know, Slack is like a chat application, basically kind of like Discord for people who know that, or IRC for the old timers. And there is this CPP Lang Slack channel. So this has got, I think at the last count, over 10,000 members. This is for everybody in the whole world to discuss the C++ language. And in particular, we have our own room in there. It's called #C++ London Uni. So what we really encourage everyone to do is to go to, it's actually a bit small on this screen if you're right at the back, I'm afraid, but the URL is slack.cpp.al. If you go to that URL in your browser, it'll have a little window. You can put your email address in there, and it'll send you an invitation with a link to join this Slack channel. And then once you do that, you can find our room, #CPP London Uni, and you can join us and you can chat to us. And there are people there most of the time to help you out with any problems. There's also, it's not on this slide, but there's also a #learn room in this channel that has lots of C++ learners from around the world and lots of really experienced people who are more than happy to answer any questions. Yes. It is thirsty work, this shouting. Apologies. Okay, why C++? You're all here because you want to learn C++. Why do you want to learn C++? Why is this C++ London Uni and not C++ Python Uni? Why do people use C++ at all, rather than some other programming language? This is not a rhetorical question, right? Come on. Not you.
Raise
Sorry?
your hand if you want to say.
Speed.
Don't be shy.
Speed, yes. Usually people use C++ because it's fast. It's fast. C++ is a great programming language for use in what people would call resource-constrained environments. And what we mean by that is where you have to do things really quickly, or where you have to use a minimum amount of memory, where you have strict limits on what you want the computer to do, where you want the results yesterday. Right? C++ is brilliant for that. And the reason it's brilliant for that, it offers a direct access to your hardware. So higher-level programming languages, things like Python and Ruby and JavaScript, there's a sort of level of indirection between your program and the actual computer hardware. Whereas in C++, if you really want to, if you want to dig down into it, you can actually really access the raw bits of your memory, more or less anyway. It has these things we call zero overhead abstractions. So yes, you can dive down to the really low level and mess about with pointers and raw memory and all this scary stuff. But actually, the nice thing about C++ is you really don't have to. We have these things, classes we call abstractions, that are on top of all this low-level, mucky, horrible, nasty stuff that make it a lot easier to use. But the programs are compiled in such a way that actually all this kind of intermediate layer, all this nice stuff kind of disappears, and your program runs just as fast as if you had done all the mucky stuff, but you don't have to. So C++ allows really, really efficient resource usage. That is really the main selling point of the language. That is why people use it. And who uses C++? Well, it's actually used kind of everywhere. So everything from like microcontrollers to supercomputers. So these huge, thousands of CPU computers they use for, I don't know, curing cancer, all the way down to perhaps a little chip that you've got in your microwave to run the timer in your microwave. That may well be running C++. It's used in the whole gamut, pretty much every device you can imagine. In particular, it's used a lot in games. So if any of you are into gaming, pretty much every PlayStation, Xbox, PC game you have ever played will have been written in C++. It's used very heavily in financial trading, in the banking industry. It's particularly relevant. We're here in the City of London. A lot of programmers involved in the financial industry. It's used, a lot of software on the laptop you have in front of you right now is written in C++. Right? If you have a web browser open, any of the main web browsers are tens of millions of lines of C++. Right? It's a very flexible language. You can use it for just about anything. So that's my C++ sales pitch, right? Did that work? Yeah? Are you now all keen going, this sounds awesome, I want to do this? Yes! Yes, you are. Yes, you are. Excellent, right. But I have to come clean. C++ is not the only programming language that exists. There are others that apparently, for some reason, some people occasionally want to use. So I have to be honest with you right up front. There are some downsides. Potential downsides, at least. So why not C++? Why do other programming languages even exist? Well, the reason people tend to avoid C++ is because it has this reputation for being kind of tricky, kind of hard. I don't think that's entirely true, and it's certainly a lot less true than it used to be. C++ has got easier over time, believe it or not. But it's not entirely a lie. As I mentioned, C++ allows us access to lots of low-level facilities. You can do really complicated, confusing things. And C++ has lots and lots of features. You can do pretty much anything in C++. Almost anything that you can do in any other programming language, there is a way to do in C++. It has lots of features, and part of the skill of learning the language is learning which features to use when, using the features wisely. And that's what, in part, these lessons are going to try and convey. And C++, as I'll say in a minute, C++ has been around for a very, very long time. In fact, it's one of the oldest programming languages that's still in mainstream use. And as part of this, it's sort of accumulated some cruft over the years. Things that seemed like a good decision in 1983 weren't necessarily a good decision in 2019. But it's not that hard. Every single person in this room has the potential to become a good C++ programmer, right? So if you go and you Google C++ and you read, there's even a Wikipedia article that is criticism of C++, right? A lot of people have quite strong opinions about this, and you might come away going, oh, yeah, I don't know about that. Don't be afraid, don't be put off, right? C++ is awesome. Yes, it could be tricky in parts, but actually, particularly when you're starting out, there are some really nice things that actually make C++ in some ways easier than learning a language like Java or C# or something like that. So what I'm trying to say basically is, don't be scared. Don't be intimidated. Don't think, I can't do this. You will get stuck. That's normal, and that's a natural part of learning, right? That's how we learn. It's by getting stuck. It's by making mistakes. Nobody is well, unless you're a genius, right? Nobody's going to work everything out for themselves for the first time. So that's what I mean about the importance of practice. By trying new things out, by getting stuck, and then you can come along. You can search on the internet. You can go to one of the many resources that are available to help you out. I mentioned Slack, there's Stack Overflow as well. And there's our Thursday sessions with Oliver over there, who will be more, yes. Hi, Ollie.
Hi.
Who is more than happy to answer any questions you might have. Anywhere you get stuck, we'll do our best to help you out. So I mentioned C++ has been around for a very long time. So because I should say, by the way, tonight is going to be an awful lot of terminology, right? So if I say something, if I will try and explain all the terms I use before I use them, if you know what I mean. But if I do slip up and I use some terminology you don't understand, please do raise your hands and say, what the hell are you talking about? In fact, if you have any questions as we're going along, you're all sitting there very, very quietly, perhaps a little bit intimidated by, this awesomeness that is before you. But please do, if you have any questions anywhere along the line, because if you're sitting there going like, I don't get this, I don't really understand, the chances are there are a lot of other people in the room who also don't understand, but are also too shy to put their hand up. So please do, I'm very, very happy to be interrupted at any point. But yeah, a very brief history of C++. So work actually started on the language in 1979, which makes it older than me, and I'm guessing older than almost everybody else in the room. So the Danish guy, Bjarne Stroustrup, who's sort of the father of C++, he started work on a set of extensions to an existing programming language called C that you may have heard of. And he called it C with classes. And he worked on this by himself for a few years, and then kind of other people got involved. And then about 1983, they decided C with classes wasn't really a great name, and they named it C++, which is actually kind of a pun, but we won't go into that. After a few years, 1990, they formed an ISO committee. ISO is the International Standards Organization. So this is I think it's like a sub-body of the United Nations even, but it does lots of international standardization for crazy things that you wouldn't even think have international standards. And amongst those are standards for programming languages. So nowadays it's actually quite a rare thing for programming languages to be standardized like this, but back in these days, this was actually a requirement if you needed wanted a US government contract. You needed to use a standardized programming language. So people wanted to standardize C++. And actually, to this day, the formal specification of C++ is all done through this ISO committee. And I'm sort of vaguely involved in that, as is Oliver. So if you hear me talking about the committee, it's this bunch of people who meet under the auspices of the ISO that I mean. So anyway, they formed this committee in 1990, and they worked for a while. And it took them 8 years. It took them 8 years to come up with a formal specification of what C++ actually is. And they published this standard, this first version of C++, and in the intervening time, this has come to be known as C++ 98. So this was the first standard version. We now refer to it as C++ 98 after the year it was released. After that, they went back to work, because once the standard is published, you can amend it, you can update it. And they went to work amending, updating, adding things, fixing things. And after a few more years, quite a few more years, in fact, 2011, they released a new major version, major update to C++, to the definition of the language, to what the language actually is. And today, we refer to this version of the standard as C++ 11. So you're probably spotting a pattern here, right? After that, they decided that actually this 13-year gap was kind of crazy. 13 years is an absolute eternity in the software world, or the computer world in general. So after this, the decision was taken that actually we're going to have a new version of C++ every 3 years, no matter what. The sort of train model, right? So every 3 years, the standard train leaves the station, is the idea. So that was 2011. Since then, we've had further updates in 2014, 2017. And right now, they are putting the finishing touches to what will be C++ 20. And already, believe it or not, starting work on what will be C++ 23, and some people are even thinking about 26, which seems so far in the future that it's crazy. So when I talk about C++ 98, C++ 11, 14, 17, this is what I mean. I mean the language has changed over time, and which version of the language I'm talking about. So in this course, we generally use the version that's C++ 14, but one thing to mention is that all of these versions are more or less backwards compatible. So if you have if you have a compiler that uses C++ 17, it's going to handle your 98, 11, 14 programs just fine. So these are sort of additions rather than complete revisions, if you see what I mean. But one thing that's kind of important to note is you might see, if you do some research on the internet, you might see this term modern C++ gets used a lot. This is a very ill-defined term that people like to use, and nobody's really quite sure what it means. Because, yeah, modern's one of those words that changes depending on when you use it, right? But what I take it to mean, and what I think most people mean when they use this term, is they mean C++ from 2011 onwards. Because C++ 11, you just saw on that timeline, there was this huge 13-year gap. And C++ 11 changed the game dramatically. It actually made C++ a much easier language to learn, a much easier language to get started with. And the reason I'm really bringing all this to your attention is don't bother learning C++ 98. It's old, it's done, it's finished. You don't want to use it. It's nowhere near as nice as this fancy new stuff we have today. Unfortunately, the internet being what it is, there is still tons and tons and tons of material on there, tutorials, websites, textbooks that still use, that date from before C++ 11, that still use this older 98 version. We very, very much encourage you to do your own reading, your own research, your own practice. Buy books, get them out of the library. We're here to help you learn. It's really the idea of these classes. But please do make sure that any textbooks you're using, any websites you might be using, any online resources, anything like that, any of those things that you're using, please do make sure that they're teaching you today's C++. There is no point learning something from 98 when, I'm guessing there are people in this room who weren't even alive then, which is crazy. But there we are. Okay. That was my pretty long introduction to what we're going to do over the next few weeks, what you have let yourselves in for by coming here. So before we go on, are there any sort of questions about this bit, about what I've just said?
I have a more general question.
Yeah.
Do we have to sign up for every lecture before the lecture? I mean, do we have to sign up every week or?
Yeah, no, we published, sorry, maybe I'll jump for a second. We published courses till end of the year. So you're very welcome to RSVP for as many you feel you want to join. This way you basically save the spot. But because we are restrained to the space, we had over 89 people at the last count when I checked, but I know that other people tried to do as well, join us. So if you decide not to come, if you could cancel the RSVP so we can free the space and offer it to somebody else, that would be appreciated. But don't wait till last day. We need to have the booking as per the agreement with the university. We need to have at least one full working day, yes, for your RSVP to be processed. And Ollie wants to add something as well.
So in short, if you want to attend RSVP at least 36 to 48 hours in advance, and yes, you must RSVP for each individual session if you want to attend. And if you can't attend, please cancel it to free the space up for someone else.
Yes?
Will the slides
Yes, I'll put the PDFs on GitHub. Yes. But not till after the session. Also, the other thing to mention, for those who don't know, is we're actually, or I guess I am, going out live on the internet, on YouTube right now. So if you can't make a session for whatever reason, but you want to follow, we live stream all of our sessions. So our YouTube channel, youtube.com/CPP London Uni. We are live now. Hello to anybody who might be listening. And also YouTube archives all of these. So in fact, almost all of our past classes are available there. And certainly all the ones we do here will be available to go back and to look after the event. If there's something you can't quite remember, just hop on YouTube. Okay. Woo. That's not what I thought was going to happen, but never mind. Right, I've been nattering for 25 minutes, which seems far too long. It's time to get you lot to do something. So, does everybody have access to something with a web browser on it?
Hands up.
Internet doesn't seem to work. I'm not sure.
Okay.
Have
Well-
you got the piece of paper?
Yes, yeah. I tried going on the usual guest thing.
Okay, well,
All right, we'll be with you in one moment. Okay, and also with anybody else who's having internet access issues. But while we sort out people's internet access issues, here is your first little exercise, right? So I want you to go to this website. It's called onebox.org. You'll load up that website. It's got a text box in. It might have some text in there already. Just delete that. And type in this little program on the right into that text box and hit run and see what happens.
Can we already do that in Semicolon?
If you know what you're doing and you want to, yeah, be my guest.
If you need a hand, just ask.
And yes, if anybody has any problems, raise your hands, and you've got me, Tom, and Ollie. We'll do our best to help you. Iostream. Yeah, I'll explain what all this means in a minute. Don't you worry.
Only the things behind the double slashes, the lines behind the double slash, whatever you want.
These are semicolons.
Don't feel afraid of it. You can run whenever you want. Usually the kind of on top.
Yeah, but it's difficult to interpret what you say. Or interpret, maybe it's not the right word. To interpret.
Just because it's using a captive portal.
Talking to doing this, I'll get myself mic'd up.
But to be fair, it was not the most intelligent choice of words. Using people was from the
Which bit?
See how
Console.
So you've got nautic, right?
Unfortunately, it won't broadcast me to the room, but it will broadcast me over the internet.
Maybe just the slides.
Sorry.
Slides audio.
Yes.
What's preferable?
Yeah, nobody needs to see me.
Personally, you prefer the backslash or the to the and the FB.
He's right there, it's much harder looking at that. No, I think just or you do them diamond. So that side and that side can both see. And then so even if you're in the middle, the diamond has two sides. So it's great.
Yeah, doesn't even know that one.
Yes.
It doesn't have the CPP.
No, it doesn't.
There's no tricks to this.
Okay.
Yeah, it will exist.
If it doesn't come up saying error or something like that, you've done it right. Okay, who's got it saying hello world in the little black box underneath? Almost all of you. Who hasn't? All right. I'm mic'd up now, so I'm just going to have to change this over for a second, so just give me a sec.
Yes, it's a classic.
Thank you. What should I do now?
Tristan, do you want to show?
Oh, hang on a second, Tom, sorry.
Yeah, you can.
I just need to...
Don't forget to change the audio source. Also, the resolution is boxed in from what we have on the.
Is it?
Yeah, I'll show you.
I don't want to cancel the thing now, Ollie.
It's not scaled right.
Well, I don't want to cancel it now.
You don't cancel it. You can just change the canvas. Oh no, I see what you're saying. Yeah, I see what you're saying. Leave it.
All right. Oh, this is getting stupid. Okay, that's where we were. Sorry about that. So, hopefully everyone's got that working. So, this is a C++ program. And you have all typed this in, and you've all clicked run, and you've all got it to work. So you are now all officially C++ programmers. So, congratulations. Give yourselves a round of applause. That's always my favourite bit of doing these. So, what has this program actually done? Well, we know what it's done. It's printed out hello world. But what do all these things actually mean? Well, to actually really get into exactly what these things mean is really, what we're going to be investigating over the next few weeks. But just to start with, it's quite useful just to go through this and just give you a sort of brief surmise of what these various lines are, why we start off doing this. Well, actually, I'll tell you why we start off doing this. Because if anybody doesn't know, Hello World is like traditionally the first program that you have to do in any programming language. It's actually, I think it's written down somewhere, it's like the law. It's like a law, rather, not like the law. You guys know quite a lot about the law. It's like a law. Somewhere it's written down that if you are introducing a programming language, the first program that must appear in any textbook or anything like that must be Hello World. So that's what we're doing as well. So the first line we have is this. / our first C++ program. Can anybody tell me what this line is, means, does? Can anybody tell me what this line does?
It's just a comment.
It's a comment, yes, absolutely. So this line actually does nothing. This line is purely for information of other programmers who are reading our source code. It's a comment. In particular, this is what's called an inline comment. So a double slash means it's the start of a comment, and that comment runs until the end of the line, and we can type absolutely anything we like in there, and it will be absolutely ignored. Right? So this is purely information. And the information in this case that we want to convey is that this is our first C++ program. There's another way of writing comments in C++. This is multi-line comments. You might have seen these in other sort of C-like languages. If you use, colors haven't worked particularly well, I'm afraid. But that's like a /* to begin a comment, type whatever you like, and then end with */. So 2 slashes, that's an inline comment, carries on to the end of the line. And then you can do a multi-line comment with this / and */. So again, if you've done any JavaScript or anything like that, that's exactly the same as you have in that language. Okay, next line, this sort of slightly weird hash include Iostream. Well, we'll get into exactly what this hash include thing does and means in probably 3 weeks' time. But very briefly, the purpose of this line is to tell the compiler, tell the system that interprets our source code, to tell it that we want to use something called Iostream. And in fact, Iostream is part of what we call the standard library. So when you get a C++ implementation on your system, which we will do probably the week after next, we'll get everyone set up with that on their own computers. It comes with a program that's called a compiler, and it also comes with a whole bunch of software or a whole bunch of code that's ready for you to use in your own programs. And that bunch of software is called the standard library. It's standard because it comes as part of the installation. And one of the parts of the standard library is this thing they call Iostream, input-output streaming. So this is the thing that actually lets you print text out. Lets you do a bit more than that. Lets you, read text as well, and a few other things. But we're using it for printing. So this says, I want to use this part of the standard library that's called Iostream. And again, we'll go into it in more depth in the coming weeks, but this hash include thing says, I want to include this functionality in my program. It's used to break our programs into smaller, more manageable pieces. So again, if you're familiar with Python, you have an import statement that says, I want to use some other module. This is, at the moment at least, the way we do it in C++. We do use this hash include. Moving on. Int main, open close brackets. So does anybody know what this line does? I don't want to use, do I have to use this?
If you swap the USB, you need to change OBS though.
Can anybody tell me what this line does?
Yes, the main function gets called when your program's executed.
It's the main function. Yeah, so this line declares a function called main. Now we'll get onto exactly what functions are in probably about half an hour or so. But functions are a way of breaking down our program into smaller pieces. And in particular, this is a function called main, and main is very special. Every C++ program contains a function called main. And main is where the execution of our program begins. So if you write a C++ program and you want it to run and you want it to do something, you need to write a function called main. The main function is a bit special. In fact, it's very special. It's got some really special rules around main. But what you really need to know is this is a function. It's called main. It's where things begin. And this function called main returns an integer. We'll get on to what it means for a function to return something in a minute. But this returns an integer, in this case, to the operating system. Opening curly brace. There's a reason I put this on a line by itself. It's because these curly braces are really quite important in C++. So this opens what we call a block of source code, a region of source code. And these blocks are really important in C++, probably more important actually if any of you have done any programming before, even with these languages with curly braces. They're even more important in C++ than you might realize at this point. So blocks kind of delineate our source code in many ways. In this case, this block contains the definition of this main function. Everything that appears between those curly braces, that is the list of instructions that we are going to execute as part of our main program, part of our program. And yes, blocks are important because they control the lifetime of variables in C++, as we'll see later. Finally, almost finally, we get to this kind of scary line. Now, there's an awful lot going on here. So let's break it down a bit. First of all, we've got this thing, std : cout. I give up on that. So what's this? Well, cout, some people say count, but I really don't like that. Cout, which is short for console output. It's an object, it's part of this standard library Iostreams thing. And this is what's called an output stream object. Now you don't have to worry too much about what that is right now. Well, what it does is it allows us to print things onto the console. That is, this text output of our program. So if any of you have used the terminal in Windows or Mac or Linux or anything like that, that's known as the console, right? So this allows us to output to the console. This cout object comes as part of the standard library. I mentioned that a moment ago. And everything that is part of the C++ standard library lives in something called a namespace. Again, a lot of terminology. This namespace thing, we're going to come back to it. But what you need to know for now is that things that live in this, things that are part of the standard library, you need to type std : before them. It's a way of, how can I put this simply? It's a way of different modules, different source code from different sources to write things in such a way that they don't clash. And the reason we put this std : is so that if anybody else is using a name cout to mean anything, we don't get it confused with the standards version of cout. That's what we mean by a namespace. This is the cout that belongs to the standard library. And lots of people, particularly when they're starting out with C++, get very frustrated with this std : Why do I have to type these 5 characters everywhere? My fingers are getting tired. My colon key is getting worn out. Why do I have to do it? Well, actually, there is a way around it, but it can sometimes lead to unexpected problems. So I tend to avoid doing it, just to avoid these potential errors. To actually make clear when I'm using something from the standard library. A lot of other sources, particularly introductory tutorials, will use this way of avoiding having to write it, just so that you have to write less. But use it with caution. So for those who know about these things, it's a bit like when you do import star or import module in Python rather than from or what is it, from module import star, you're bringing everything into your namespace. We can do that in C++, but it's not always a great idea. Oh, we're not getting line by line anymore, never mind. So we have this cout object, and then we're using these double chevrons, this left shift. And what this is saying is, well, this is a stream. It's a stream object, and we want to, if you think of it as like a literal stream, we want to chuck things into this stream so they get transported to where they need to go, right? And where they need to go in this case is to our output console, to our console output. So using this indicator is saying, I want to put this thing into the stream so that it gets transported to the output. There are other kinds of output stream, by the way. You can have like a file output stream. You could, if you wanted to, have a network output stream. There are various different streams you can use. In this case, we're using the console output stream. So this says, please transport this to my output stream. And the thing that is being transported, why am I not getting individual lines anymore? This is annoying. Never mind. The thing that's being transported in this case is the string hello world. So a string is a fancy computer science term meaning a bunch of characters, a bunch of letters, numbers, those sorts of things. So in C++, so this thing is called a string literal. That is, it's literally a string in our source code. And we write a string literal by enclosing it in double quotes. So in this case, the string we're using is hello world. And then we have this funny /n thing at the end. What does that do? Well, you can see it on the screen there. This inserts a new line. That is, it says, please start a new line wherever you see this, where you substitute it for this /n. So what this is going to print is hello world, return, effectively, start a new line. There is another way of doing this that, again, you might see in textbooks, you might see in beginner tutorials if you go looking for these things yourself. You can do it. There's another thing called standard endl end line that some people use. There are slight differences, but basically I prefer this one because it's slightly less typing, and I'm really lazy, so.
Is everyone clear on the /n and that it's sort of magic?
Yes.
Confused by that yet? Computer treats a backslash specially, so it looks at the backslash and says, "Oh, you're going to do something special," and then looks at the next character to see what you want to do. So n means new line.
And finally, the last but not least character on this line is this semicolon. So semicolons are very important. Semicolon at the end of a statement is basically like a full stop at the end of the sentence. It says to the program that reads your source code, it says, okay, this is the end of this statement. We're going to move on to the next one. So it's the full stop at the end of the sentence. And you will forget to type it, because I've been doing this for years and years and years, and I always forget to type them, right? If you do that, the compiler is the program that reads your source code. It's going to bark at you. It's going to say, I didn't understand that, because the compiler is really fussy. Actually, it's kind of smart. It usually will say to you something like, I expected you to put a semicolon here. You've made a mistake. And then you go, oh, okay. And then you go and you put it in, and then the compiler's happy. Very occasionally, you can get strange errors. A bit like you would in English. I can't think of an example off the top of my head, but you can imagine there are cases where if you left out the punctuation, you had two sentences might run together and form something that's like a valid sentence but doesn't make sense. Yes. Something. Yes. No, I help my. No, I'm not doing that one.
Don't do that.
Yes, so just like in natural language, punctuation is important. in this case, the semicolon says we're ending a statement, like a full stop. Return 0. So I mentioned main is a function. It's a special function. It's a function that automatically gets run effectively by the operating system when your program starts. And main returns an integer, there's a number basically, returns an integer back to the operating system after your program finishes. It's like a status code. And just by convention, this is purely convention, there's nothing enforces it, but by convention, if everything went well, if your program ran happily, if there were no problems, we return the value 0. I guess to say nothing went wrong, there were no errors. I don't know why this convention exists. It's existed for, since the 70s, but if everything worked happily, we return the value 0. And again, the convention is if we return any other value from main, that signifies there was an error. And really old school like Unix programs from 50 years ago, they have a bunch of error status codes that you could go and look up in the big thick manual that you had on your desk when you were Unix greybeard in 1975. A little less useful these days, but we still do these things. Yeah.
If you remove return 0, does it compile?
If you deleted this line, from your program, would it still compile? Yes.
Why?
Why? I think you already know the answer, Lauren. You're just testing me, aren't you? Why? Okay, so in this particular case, main, I mentioned this, is a very, very special function. So main has all sorts of special rules, and one of these special rules is that if you don't put a return statement at the end, but only in the case of main, it will return 0. It will do return 0 for you automatically. Right? That rule only applies to the main function, and because it's...
He said, will it compile? It will always compile for any function.
Will it work?
Will it be correct?
So yes, for main only you can leave out this return 0, and probably in future sessions on the slides I will actually do that from main just to save some room on the slides. But for any other function that isn't main, you do have to have an explicit return statement. And then finally, the last little character is this closing semicolon. And there is a reason I put these things on their own lines. It's not just to make it look pretty. It's because especially this little guy, this closing curly brace, believe it or not, this is the very best feature of C++. I'm not making this up. This is the best thing about the language. So if you're kind of new to this stuff, what I'm about to say, probably is like, what? But if you are familiar with other programming language, perhaps you've used garbage collected languages in the past, you're used to another, not literally another CPU, another process, another operating system process, but there is some sort of background thing that is looking after tidying up all your garbage once you finish using it. C++ is not garbage collected. The lifetime of our variables is controlled by their scope, by the blocks in which they live. So when we exit a scope, when we exit a block, all of our local variables get destroyed. Everything gets cleaned up for us. We don't have to, there's no garbage collector pause. We don't have to wait for any of that stuff. Deterministic, this is what's called deterministic destruction, and it's one of the things that makes C++ really awesome. Okay, for the rest of you who are, here for the first time and are not kind of familiar with Java or whatever, we'll get to what that means in the next few weeks, so don't worry about it for now. But I'm not kidding, this really is the very best thing about C++. This little curly guy. Yes.
The curly brace exists in other languages. Are you saying that it's different?
Okay, so the curly brace exists in other languages, yep. So if you use something like Java, JavaScript, C#, whatever, they all use these curly braces as blocks of source code. So like your function definition, you have like a block of source code that says this is the list of instructions that belong to this function. That's what C++ does as well, but there's sort of like added functionality on top of that. Special stuff happens at the end of a block in C++, is what I was trying to get at. But we don't have to worry about that too much for now. That's just me really kind of dangling a carrot, tempting the people who are already Java programmers out there going, I know this stuff. I'm going, well, no, there's another, there's more. There's a reason this is so cool. But we'll get to it, don't worry. Not today, I should say, in the next few weeks. Apologies, one moment. Yeah. For some reason, all my nice transitions seem to have dropped off. So we're not getting a nice line-by-line thing, and everyone's getting way ahead of me, and you know, I can't handle that. So I have to go and add them back in. Won't be a second. Right, where were we? Magic. Right, I have mentioned this word compiler several times already. Now, I said to you I'm going to explain I'll try to explain the terminology before I get there, but already we're an hour in and I've slipped up already. So, the compiler. What is a compiler? Does anybody tell me what is a compiler? This thing I've been talking about.
It's a program to transform your source code into different code, like assembly or binary.
That didn't come out on the speaker probably, but it's a program that transforms your source code into some other form.
Yeah.
That is an absolutely perfect textbook answer. Yes, that is exactly what it is. Yeah. Yes.
I think it compiles all the block of source code into one.
It compiles the source code that you give it.
All the functions together and then gives the result. That's what it does.
Not entirely. It doesn't. So if that didn't come out, does it sort of combine all your functions together into one? It's not exactly. It takes your source code and it transforms it into some other form. So the compiler is a program on your system that reads C++ source code and performs this process we call compilation and outputs some other form. In this case, the form we're interested in, it creates a new program that you can run on your computer. Right, so the compiler is a program that generates a new program. And C++ is what we call a compiled language. That is, it's a language through which we have to, so we have our source code, we give that source code, this text file, we give it to the compiler processes that, and it gives us a program that we can run. So this is a bit different to, say, Python, if you're familiar with Python. Python is an interpreted language. So all you do is you point the interpreter at your source code, and it kind of does it all in one go. In C++, this is like a two-step process. The compiler takes our source code and transforms it into a program that is an executable, something we can execute. Turns it into an executable that we can run. So this two-step process is actually great because it means that a lot of potential errors can be caught at step one. be caught at the compilation stage. We call these compile time errors. They happen at compile time. They happen at the time you compile your program. So, you know, for most programs, if it's something you're distributing to people, most programs you're going to run this program many more times, perhaps millions more times than you're going to compile it, right? Perhaps you're producing the latest hit PlayStation game. Well, once you finish development, you compile it. Millions and millions of people are going to run your program. So you want as few errors in your end program as you possibly can. So one of the advantages of this two-stage process is that we can do a lot of checking of the validity of our program at the first stage, at this compile time stage. And in fact, in C++, we strongly prefer compile time errors to errors that happen when you run the program. We call those runtime errors for obvious reasons. We strongly prefer compile time errors, and people go to, I'm not kidding, go to absolutely enormous lengths to try really, really hard to turn potential runtime errors into compile time errors instead. The other thing that might happen when you do this for yourself is that the compiler will give you warnings. So it will say to you, okay, what you've done there, kind of, I understand what you mean, but you know, it's probably not doing exactly what you think it's going to. This might work okay in most cases, but perhaps there's a problem you haven't considered. Compilers give you warnings, and you can ignore them. They're not errors, they're just information, effectively. But it's always a good idea to heed the warnings the compilers give you. And in fact, there are ways that you can ask the compiler to give you even more warnings than it does by default. And a lot of people do that, and it's actually a really good thing to do. It's to enable as many warnings as possible about potential problems in your source code. So one box that we use for that last exercise, it's an example of an online compiler. So what happens is that behind the scenes on some website somewhere, there is a computer that's running a C++ compiler, and it takes your source code that you typed in that box, and it runs the compiler, and it gets the output, and then it runs the program that it generated. So it's doing this two-step process behind the scenes, but it's making it look like it happened all in one step just when you hit run. What was actually happening behind the scenes was that this program, called the compiler, was taking your source code, producing an executable, and that executable was being run, as I say, like on some web server somewhere. So schematically, the process looks like this. And I'm emphasizing this because in the past we've had like a lot of Python programmers, Ruby programmers, JavaScript programmers, where this process runs is quite different. But for C++, it works like this. We take our source file, that's just a text file with all those lines I was just going over. Takes our source file, we push it through this program called the compiler, and it produces another program that we can actually run on our machine.
When you say you push it through the program called the compiler, you have to have that installed, or is
You
that
need
built
to.
into the machine?
You need to have a C++ compiler installed on your computer. So just kind of to get everybody started today, we use an online compiler. So that's some web server somewhere that's running it just to make things easier. But for later on in the course, you'll need to have a C++ compiler installed on your computer. But probably the week after next, we'll go through and we'll help everybody get a compiler installed. We'll tell you where you can get them, how you can get it installed, and we'll help you get set up. So for today, you don't actually need it. I mean, if you have it, I think somebody does. If you already have one and you know how to use it, that's great. It's not required for today, but in a couple of weeks' time, we'll help everybody get set up. There's actually an interesting, just as a bit of an aside, there's actually an interesting thing that somebody asked me last time we did this, is what language is the compiler written in? Well, actually, almost all the compilers are written in C++. So how do you get so how do you compile the compiler in the it's actually a serious problem. It's a problem that's called bootstrapping, right? It's pulling yourself up by your bootstraps. How do you do it? So this is actually like a genuine, quite complicated thing. If you've got, how do you generate the compiler in the first place? But anyway, that was just a question somebody asked me last time, and it's kind of an interesting, like, philosophical point to consider. But we don't have to worry about that. We're not writing compilers, well, at least not yet. That'd be quite an interesting thing.
One for the public, anyone's interested.
Yeah, absolutely. I just like to throw in these moral quandaries sometimes. All right, so if you're in a trolley and three of your... No. Let's move on. Let's move on to another important notion, really important notion in C++, that you might have come up against if you've done any sort of programming before, but it's really, really important in C++ and really important to get to a really good understanding of. And that's this notion of types. So your computer works on ones and zeros, right? You all know that. The memory in your computer, the RAM, it's just billions upon billions of ones and zeros. That's all it is, right? Your hard drive or your SSD or whatever you've got, ones and zeros. That's all computers know about. That's all they do. But what do those ones and zeros actually mean? Why does this bunch of ones and zeros represent somebody's address, or this bunch of ones and zeros is an MP3, or this bunch of ones and zeros is a JPEG? Well, that association, we call that association the type of some memory. We associate some data, some ones and zeros, some bytes. We give it what we call a type. A type is a way of giving meaning to some data. Now, you are all probably familiar with the notion of a type, even if you haven't really considered it before. Right? If you use Windows, if you change the extension of a file, you know, if you've got a Word document and it ends .doc, or used to, they've changed it now, but, and you change that to MP3, well, Windows is suddenly going to pretend that's an MP3 file. And then you double click this new MP3 and your MP3 player is going to go, what? I don't understand that. And the reason is because those sequence of ones and zeros that made up the Word document, well, if we try and interpret those as an MP3, that makes no sense. And this notion of types in C++ works exactly like that. It gives us information about what this data means, what these bytes mean, and by forming this association, we can prevent errors. We can prevent trying to open an MP3 in Word, which, trust me, you don't want to do. The type of some data tells us what that data represents and what we can do with it. So, for example, we can multiply two numbers, right? We've got two integers. What multiplication means is well defined. But we can't meaningfully multiply two strings. Like, what does carrot multiplied by banana mean? Like, it's just meaningless, right? So types tell us what the data is, what it represents, and also what we can do with that data. And C++ actually gives us a whole bunch of types that are built into the language. We call these fundamental types. And it also has a great many facilities for building our own types, for defining our own types. So we could have a type that represented a Word document. We could have a type that represented an MP3 if we wanted to. Usually you break it down into something a bit, smaller than that. But you can compose these things. You can build up types out of simpler types. You can build these things up, compose them, and actually the reason that for this composition is why these built-in ones are called fundamental, because they're the lowest level. They're the ones from which everything else gets composed. And the standard library that I was talking about earlier, this sort of repository of software that comes with your compiler, the standard library also provides many useful predefined types. So this notion of type is absolutely critical to kind of getting a handle on how C++, or compiled languages in general really, how they work. We, by and large, have to be very explicit about the types we use in C++. C++ is what's called a statically typed programming language. This means that every single piece of data that we use in our program has a type associated with it. And that type is determined when we compile our program. So again, this is fundamentally quite different to a way a lot of other programming languages work. This notion of type is central, is really, really important. And C++ has this feature called type safety that will prevent you from attempting operations that don't make sense for the type of data you're using. It allows, it's part of, I was talking about compile time errors. Well, this type safety is a big part of it, preventing you from doing things that don't make sense for the kind of data you've got, the type of data you've got. These are things that can be caught by the compiler. It will give you an error message because it senses that you're trying to do something wrong. So it's a really important safety feature, a correctness, I should say, really, rather than safety. It's about the correctness of your programs. And there are escape hatches. There are ways around these type safety rules. We can do things like casting. Avoid them if at all possible, right? There are these escape hatches. By and large, if you need to use these escape hatches, except in some special cases, if you need to use these escape hatches, it's usually a sign that maybe the design of your program is not quite right. Right? Maybe you have to go and rethink how your data types are defined. So I mentioned that C++ provides us with several useful data types just out of the box. Lots of features to define our own types as well, but it gives us a few really useful ones out of the box. So I'm going to have to use a different color than yellow next time, aren't I? So apologies if you're at the back and you can't really see that. That says int. So int is one of these built-in fundamental types, and it represents an integer, that is a whole number. Like 0, 1, 1, 2, 3, 4, 5, minus 5, 4, 3, 2, 1, right? A whole number. There's also float. And this is short for floating points. Don't really have to worry about that, but it's a real number. That is a number with a fractional part. 3.142, 2.718, minus whatever that is, 1, 2, 3, 4, 5.456. So integers, ints are whole numbers, floats are numbers with a fractional part. And in fact, you might also see there's another kind of real number that's a double. Doubles and floats are almost exactly the same thing. A double just has a bit more precision. So, mathematically, it's sort of conceptually these things have infinite precision, but we deal with computers that have like finite resources. So we have to like cut off the precision at some point, otherwise our programs will use infinite amounts of memory and we'd be in all sorts of trouble. So we have a finite amount of precision, that is a finite number of decimal places that this thing can store. And there's double, which is twice the size of a float and can hold, effectively more or less, hold twice as many decimal places before it starts losing information. So yeah, you might see double as well in examples online. There's this type bool. Bool is really useful because it can hold only one of two values. It can either be true or it can be false. And that's it. And this actually turns out to be really, really useful in a whole bunch of places. Boolean is named after this like mathematician from like the 1600s, I think he was, Robert Boole. And he came up with this like foundation of Boolean logic where everything's true or false. In computer science, these things are called bools, named after him. It's a true or a false value. That's it. Finally, there's this thing that, or not finally, but next is this thing that nobody can quite agree on how to pronounce. Depending on who you ask, it's either a char or a car, or a chair or a care, or I don't know. I mix it up. Sometimes it's a char, sometimes it's a car, depending on how I'm feeling. I'll probably say both as we're going along. But this represents a single character. That is a letter of the basically English alphabet. Lower letters, capital letters, and some punctuation as well. So if you've done a lot of this stuff before, if you know what Unicode is, this is most definitely not that. Right? This can only store a very limited range of characters, as I say, basically 26 uppercase letters, 26 lowercase letters, numbers, and a few punctuation symbols. So, it's no good if you're writing software that needs to be used by people in Thailand or India or basically anywhere in the world outside Europe. But for the purposes of what we're going to do over the next few weeks, car is fine and car is great, or great. Car is perfectly fine for what we're going to do. Why did I mention car? Well, because it's an important part of this type that really is very useful, which is a standard string, std : string. And a string represents a sequence of characters, a sequence of chars. And a string, again, just one of these kind of computer sciencey terms, it's basically just some text, some letters and numbers, some text. We call that a string, if you hadn't heard the term before. And this type, this std : string, this, as you can see from the prefix, from this std prefix, comes from the standard library. So this is one of these standard library types that are predefined for us that we can use in our programs, that we will be using in our programs. There's also a thing called a standard vector. So a standard vector is a sequence of some type. So a string is a sequence of particularly of characters. A vector is a sequence of something, some type. A bunch of things that are all of the same type. So for example, we've got a sequence here, 1, 2, 3, 4. That's a sequence of integers. We've got this sequence 0.0, 0.1, 0. Or minus 0.1, minus 0.2, minus 0.3. That's a sequence of floats or a sequence of doubles. A vector is a sequence of things that all have the same type. It's what you might... They refer to these things often as arrays in other languages, or an array list. This is actually an example of a generic type. So again, if you've done any programming in something like, say, Java or C# or anything like that, they have these things called generics, and C++ has that as well in a slightly different form. And standard vector is an example of a generic type. So we'll get on to what that means, how you use it. Probably next week. Certainly next week, we'll have some examples of using a standard vector. So these kind of half a dozen things, there are many, many other types besides these. Probably, but with these and with double, these are going to be sufficient for us to compose all the examples that we're going to be using over the next few weeks. Yeah, as I say, if you go looking online, you'll probably find, you'll see the list of all the 40 or so fundamental types that are built into the language and get really scared. Don't worry, these are kind of the essential ones. These are the ones you need to know about. So, because this is quite an important thing, I would just want to make sure like everyone's on the right page, everyone's on the same page about what I mean by the type of some data. Is that kind of clear? People kind of understand what I'm on about. Associating meaning with some bytes, with some ones and zeros. Is that? Any questions about what I mean by types? No? Awesome. Cool. We're going really well. I'm going to finish early. Pub sooner. Yeah. Are you still a student? All right, let's go on to talk about functions. So, well, perhaps someone else can tell me, actually. What is a function in a computer programming sense? Yeah, go on at the back.
It's
A
a routine.
routine?
Yes.
Okay. Something you do every day, like drudgery.
Yes,
Yeah, so a routine or a subroutine is another name, I guess, for a function. But what's that? What do I actually mean, Michael?
Well, it's kind of a program inside your program. So your program might want to do something which is quite complex. So it calls like a small, tiny program that solves the problem, and then comes back to your actual code.
Do people hear that? Yeah. It's kind of like a small, tiny program that does something and then returns the result back to where it started.
like a formula.
Like a formula. Yeah, that's a good. Yeah, your hand up. An operation done on some data. These are all really good answers. Ollie, I think.
I don't know what you're going to say, so I'm going to say it because I want to see if I match you on this one.
All right.
It's something that takes some input, processes it, and may return some form of output.
That is pretty much what I'm going to say, yes. Okay, so pretty much, well, certainly every programming language you will ever want to use in real life, they have some notion of a function. So a function, so as in all languages, really have this feature. It's not really a feature, it's like a fundamental, really. They have this idea of functions. That's like a small piece of code, of reusable code. And we can build up our program out of these functions. And a function at its heart is just a list of instructions. A list of instructions to say, do these things in order, one after the other. And then once you finish that, come back to me. Right? Almost like a recipe. Or like Michael said, like a sort of mini program inside your program, sort of, kind of. We've already seen a function called main. This is a very special function that actually gets basically run by the operating system. It says go and execute this list of instructions, and then come back to me when you're done. Yes. This is like a little note for, again, when I do these things, we have people with all sorts of different backgrounds coming along. So again, if you're from like a Java background and you're thinking, well, he's talking about functions, does he mean methods? C++ has methods or member functions, as we call them. It has them as well, but we're not going to worry about those for now. We're talking about what we call freestanding functions. So if you know what methods are, don't worry about that too much. Right now, we'll get to them in future sessions. So a function takes some input data, it does something, performs some calculation, and then it returns some output. Right? That's the idea of a function. You give it some input, it does stuff, and it gives you the result. Where stuff is the list of instructions that we're telling it to do. Input, stuff, output. Right? Well, that's the general case. However, there are lots of cases, for example, where functions don't necessarily have any useful information to return. There are some functions that don't actually need any input data. It's possible to have a function that has neither input nor output and just does stuff, although I'm not really sure how useful those are. So in C++, we write our functions, we give them names, we give them input data, and they return some output. Usually, probably. In C++, a function can have any number of input values. We can give a function as much input as we like. And these input values, these pieces of data we supply to the function, we call those function parameters. So we can have as many input values as we like, but a function in C++ at least can only return at most one output value. We call it the return value. It's what the function returns to us when it's finished. Now, the function doesn't have to return any data. If it doesn't, that's fine. It's got 0 return values. So a function may have 0 or 1 return values. I'll just spend a bit of time talking about the importance of types in C++. And one of the things that, again, might be a bit new to you if you've done programming in other languages, is that in C++ we have to write the type, tell the compiler the type of each of our pieces of input data, and we have to tell it the type of the data that this function returns. We have to write our types everywhere. This notion of type is really important, and we need to be explicit about what kind of types our function operates on and what type of data it returns. So here's an example of a function. So this is a function called add. It's not a very inspired name for a function, but you know. And this function add takes two inputs. It takes an input we've named A and an input we've named B. And in this case, both inputs to this function, both of these function parameters, have type int. An int represents an integer, a whole number, yeah. So this is one of these built-in fundamental types that represents a whole number. Right, so this is adding two integers. And this function returns a value of type int as well. So the way we read this definition, we say this is a function that returns an int, it's named add, and it takes two parameters which are both of type int. So this notion of type is really, really important. We have to write our types almost everywhere. Every time we're using a piece of, almost every time we're using a piece of data, we have to tell the compiler what the type of that data is. So in this case, this is a function that operates on two ints and returns an int. So the return type goes first. That's just the way it is. So the return type is int and returns a value of type int, the return type. And then between these curly braces, we have the list of instructions of what this function actually does. And in this case, the function only does one thing, and that's to return this built-in operation on ints of adding the two things together, of adding a plus b. So a refers to our first input value, b refers to our second input value. These things are like built into the compiler, so it knows how to add ints, which does exactly what you think it does. And then from our function, we want to return whatever the value of a plus b is. So yeah, add is kind of a pointless function because it's actually just doing something we could do easily ourselves. But it shows you nicely, or it shows simply the syntax of these functions, how we write functions in C++. And again, if you've done any C or Java or C# or whatever, this is pretty much exactly the same syntax that is used for writing functions in a whole bunch of other related languages as well. So return type, name, and then its input data in round brackets.
Question?
Yeah.
Can we have a union of types? So like in parameters, so you can take either one type or the other?
Can we have a union of parameters?
Yeah, and like type, so union int or a string, or that's not possible?
Not directly. I think, if I understand what you're saying, right, I don't think we can do quite what you are after. So one thing to note, by the way, it just so happens that this function takes two integers. Right? We could take two values of different types. We could have any kind of types we like. One thing we can do is to have like a generic function that can operate on any sort of type. That's like pretty advanced. That's way down the line. Now that I think about it, there is actually a way that we can do this union thing, but it's, I don't know. It's not all that simple for me to explain right now. So it is kind of possible. Variant, were you going to say? Yeah. So here's an example of a function that takes two inputs, returns an output. In this case, they all happen to be the same type, but they don't necessarily need to be. So here's another function. This time it's called print float. So how many pieces of input data does this program take? How many input values? So does this function take? Yes, this takes one input value. We've named it f. And this time our only input value is of type float. It's, as I say, a built-in type that represents a real number, a number with a fractional part. This time the action that the function performs is to, as its name suggests, print out the value of the float that we've passed into it. So again, as we saw from the Hello World example, we have this funky stream object, and we're putting this float into the stream so that it can get transported to the output, which is like the console on our screen. So this prints out the value of f, and that's all this function needs to do. This function has no useful information to return to us. Right, so this is an example of a function that has no output, no return value. Yes?
What is the COUT?
Oh, cout. Yeah, so that's it's short for console output.
Oh.
Yeah, I know. So if you've done programming in other languages, most languages have like a print statement just for printing stuff. C++ doesn't yet. It will actually. It's part of this new C++ 20 stuff I was talking about earlier. But in their infinite wisdom, they decided that in order to print stuff to the screen in C++, you were going to use this magic streaming stuff. So this is what we call like a stream object. Think of it as like a transport stream. Like it takes this value and it transports that value somewhere. And in this case, this cout is a stream that transports it into your console, prints it out effectively. So this is, other languages would probably just say something like print brackets f. In C++, we do printing like this. So again, if you look at examples online, you'll probably see things like this in many places. So as I say, print float has no useful information to return. We don't need a return value from this function. So this time, we've written its return type as this special type void. So void is a special type, sort of untype really, that says it's used, it's kind of a placeholder to say this function does not return any data. So if a function does return useful data, then we write the type of the data first. If the function doesn't, then we use this special return type void. So that's how we write functions. We can write some functions, but how do we actually run those functions? How do we call these functions? So we do that. Once we've defined our function, we can execute that function from another part of our source code by writing its name, followed by the input data we're giving it in round brackets. So we might say something like print float, brackets 3.142 f. This is a floating point value. So if we had our print float function that we'd already written up there, we'd write print float and then the value in brackets. When we have a function that takes multiple inputs, multiple parameters, we write them in this list between the brackets, separated by commas. So if we had add and it had more, we might have add 4, 5, 6, 7. If we had a function that was going to take lots and lots of ints. And when the compiler sees it's processing your functions, processing your source code, and it sees a line that looks like that, followed by a semicolon, what it will do is it will go away and it will run that function. Or it will actually insert a call to that function.
Why does the print float have to have like an underscore between the print?
Oh, that was just what I happened to name it. So that was just my name. There's no like.
No, okay.
You can name this pretty much whatever you like. You're restricted to like normal letters, but you can use lowercase, uppercase. You can put numbers in there as well. just so happened I find things easier to read if they're like words separated by underscores. So.
You can't have spaces.
You cannot have a space in a function name, no.
Can I upper lowercase?
Yeah.
And
Yeah, you can't use any sort of punctuation. You can't have spaces or colons or semicolons or brackets or anything like that. Upper or lowercase letters, and you can use numbers, but not as the first character. Anywhere other than the first character, you can use a number. Oh, and if we're really getting pernickety, it can't begin with an underscore either, except in some. No, don't begin it with an underscore, and you'll be safe.
Or star.
So C++ has this really kind of funny rule that we need to declare functions before we use them. That is, the compiler reads your source code from top to bottom, like a human reading a book, or at least in the West. Reads it top to bottom, left to right. And at the point at which it sees that you're calling some function, it needs to know what that function means, what it is. In particular, it needs to know this because for this type safety, actually, that's the reason it needs it. But it means that you need to actually arrange your source code in such a way that your functions literally appear above in the source code, above the point at which you use them. This is something that is one of these things that occurred basically because C++ was so old. Once upon a time, believe it or not, compilers machines didn't have enough memory to process a whole text file in one go. So they processed each individual function one at a time. Because they didn't have enough, we're talking about machines with a few kilobytes of memory when C++ first started. It has this very strange rule that other languages have mostly got rid of, that we have to arrange our source code in such a way that we write our functions first before we call them. So it's just something to be aware of, that if you don't do this, you'll get funny errors. Basically, the compiler will say, you've used this, looks like you're calling a function, but I don't know what this function means. And you're going, you're an idiot, compiler, it's just down there. But what it means is it can't be down there, it has to be up there. It has to be above the point at which you use it.
So that all of the functions have to come at the beginning of the actual source code. You can't have them in between if you finish the block and you're about to start writing something else and have a function just written down.
So you can't define a function within another function, right? But yes, essentially, let me show you an example of what I mean. Yes, there we go. So here we've defined three functions. We've got printInt, get1, and our familiar function add. Sorry if this is very small at the back, by the way. As I say, there are a few free seats at the front if you're struggling. So we define three functions, and then we've got this main function down here. And what we really want to make sure is that when we define our own functions, that they go above main. We just write them first in the source code. If we wrote these down here, then it wouldn't work. So that's really all I'm trying to convey by that. It's just one of those sort of little, I mentioned at the beginning, C++ has been around for like 40 years. It's got some warts, some things that we're like, oh, really, do you have to? And this is one of those unfortunate things to be aware of. So anyway, let's have a look at this example. So I've written these three functions, and in each case I've written them all on one line just to try and fit it all on the slide. But also, kind of doing so to illustrate a point, is that the C++ compiler doesn't care at all about how you lay out your source code. It doesn't care about spaces, it doesn't care about how many things you put on a line, doesn't care whether you use tabs or spaces. It doesn't care. Layout, your source code layout is unimportant in C++. So it's not like, again, I keep going back to Python, but Python's kind of a good example of the opposite of everything for C++. So in Python, how you lay out your source code is really important, right? In C++, it's not. The compiler really doesn't care. It basically just ignores all white space. So in this case, I have written this print int function all on one line. So print int is basically the same as the print float function we just saw on the previous slide. So this is a function that takes one input parameter of type int, it returns nothing, and the action that it does is to print I, to stream it, to pass it to the output stream, followed by a new line character. So again, we're starting off simple and just introducing a little bit more. So these streams have the kind of magic property that you can pass multiple things to them, one after the other. So here we are passing I to the output stream, and then we're passing a new line, this /n that we saw back in the Hello World example. So this will print whatever the value of I is, followed by a new line of return statement, effectively. Then we've got this function get1. And get1 takes no input parameters in this case. I wanted to show you an example of a function that takes no input parameters. And it returns us an integer. And in fact, it's always just going to return us the value 1. This is the least interesting function that I'm going to show you on any of the slides ever, probably. This is a function that always returns the value 1, and appropriately enough, we called it get1. Then we've got our add function again, all squished onto one line this time. But as I say, the compiler doesn't care. The compiler will read this just the same. So this function is named add, takes two parameters, both of type int, returns an int, and the return value is calculated as a plus b. So these are the three functions we've defined, user-defined functions that we've written. And then we get to our main function. So remember, every C++ program needs to have a main function. And main, I didn't mention this earlier, but main must return an int as well. That's very important. So what do we do in our main function? Well, the first thing we're going to do is we're going to call our print int function. So what's going to happen, conceptually at least, is the operating system is going to launch our program, and we're going to launch into our main function. And the first thing we're going to do is call print int. So control of our program is going to jump up here, up to this function. Calling print int, and we're passing it the value 3. So, what is this function going to do? Sorry? It's going to print 3? Sorry? Print 3 followed, yes, perfect. Print 3 followed by a new line. Absolutely. That's pretty cool. So that's all this function is going to do. This function doesn't return any value, so that's fine. We can just exit from this function. We get to here, except we don't because white space isn't important. We actually jump straight to this. Now, this one's doing something kind of interesting. Because this is calling print int again, but what's the value that we're passing to print int? Well, it's whatever the return value of this function is. So again, it's going to look at this and go, okay, in order to call print int, I need to work out its input values first. I can't call the function without giving it any input, right? So first of all, it's going to run this add function. And in this case, we're going to give it the argument, we're going to supply it the input data 4 and 5. So we're going to jump up here. A is going to be equal to 4, B is going to be equal to 5. It's going to compute 4 plus 5. Fingers crossed it's going to give us 9, or things are really bad. It's going to give us 9. So this add function is going to return the value 9. We hope. And this value 9 then functions as the input to print int. So this whole line here, up to this semicolon, this is going to print the value 9, followed by a new line. That's the end result that we're going to get. But I want to show you this as an example of the fact that we can sort of compose these functions. We can use the output of one function as the input to another. And in fact, we can make it even more complicated than that because, you know, why not? Why not stretch it a bit? So we come down here. So the instructions get run in the order that they're written. So we run this print int. We want to call this print int function. In order to do that, we need to work out its input data. In order to do that, we need to run this add function. But now hang on a second. In order to do that, we need to run this function. So we're going to run this function, and control is going to jump up here, and it's going to see, okay, well this function takes no input data, so I don't have to calculate anything there, that's good. This function is going to return the value 1. So the first parameter to add is going to have the value 1. And then it's going to work out the second parameter, and well, it's going to go through exactly the same process. It's going to run this function, it's going to get the value 1. Okay, so now it's got a 1 and a 1, and it's going to pass those two values to this add function. So it's going to add 1 and 1, and this time we really, really hope we get 2. And then the result of this function, this value 2, is going to be provided as input to print int.
So does this follow like a sequence? How does it know, like in mathematics, when you have them in the brackets, it knows to run what's in the bracket? Does it follow the same thing, or does it just go to the same how you've declared the functions?
Sorry,
so like what you've got quite a few brackets in there.
Yes.
So would it go to, which one would it go
Okay,
to?
so what it does is it starts here and goes, okay, I want to call this print int function. But in order to do that, I need to, well, let's go to this line because it's a bit easier to start with. Okay, in order to run this print int function, I need to know what input data to give that function, right? You can't run the function without like giving it some input. So in this case, it's really easy. The input value we've just written 3. That's fine. In this case, in order to compute the input, in order to work out what the input value is, it has to run another function. So it sort of almost does it inside out. It runs this function first, computes the value 9, and then passes that 9 into this function print int. So yeah, it almost sort of does it inside out. You know, it runs this one first and then this outer one. And in this case, it gets even more complicated because it runs these two inner functions first, then this one, and then this one. Sort of like nested, just building up these things. Yeah.
Which of the two get ones will it call first?
Don't know. Don't be awkward. Don't be awkward. So the reason for showing this slide is not because I wanted to confuse you with, you know, all this inside-out calling business. Because actually, to be honest, especially this last one, you would never realistically write this. I just wanted to put it on the slide just to show you it's possible, just to show you that the C++ compiler will make sense of this. Although something like this is a bit more common. passing the output of one function straight into another function. And I want to give you a sort of get you used to thinking about, okay, well, a function takes some input, it potentially returns some output, and if it returns that output, we can use the output as the input to the next function.
You've got, sorry.
No, no.
I'm slightly confused at the bottom. So after that, I understand that would be 1 + 1.
Yeah.
But return 0.
Okay.
Like a true or false,
Okay, so I mentioned this earlier, but so the main function is this really special function that gets called effectively by the computer's operating system. When you run the program starts running from here, it executes these instructions, and then the operating system expects our C++ program to return like some sort of status code. This is just like a convention from like Unix systems from like 50 years ago. So programs are expected to return a status code, and just by convention, a status code of 0 means everything's okay, everything's fine, everything's good, everything's happy. So as the final thing we do before our program exits, we say to the operating system, hey, everything was cool, our program's fine, it did everything we expected it to do. So inputs and outputs. Sorry, Lauren, yeah.
Just a minor point. On the first line, why did you put the /n straight after the variable I? The next line, you could have put it immediately after I.
There?
Yeah.
So without the //
Yeah. What's the difference?
What's the difference is that wouldn't work.
Alright.
So this is so this says, first of all, I want to pass this integer, and then I want to pass this like special magic character that means new line. So first I want to pass that, then I want to pass that. And if you tried to leave that out, it'd be like sort of munging two words together that make no sense. It'd be like a spelling mistake. It'll say, I don't know what I followed by an opening character thing means, an opening quote means. That's like a syntax error. Yeah.
Is it because they're different types?
It's not actually in this case because they're different types, it's because they're different things, different values, right? We've got an int I, or rather, it's not even that. It's this is the name of a variable, and this is, in this case, what we call a character literal. But they're different things. So we can imagine we had a function like print 2 ints, and we had two pieces of data I and j. Well, we'd write that as standard cout, arrow, arrow, I, arrow, arrow, j. And if we left out the two arrows, the compiler would just see, like, what is I followed by j? I don't know what you mean. What do those two things mean next to each other? Right? It'd be like a sort of spelling mistake. So is everyone sort of fairly clear on what a function is and what we mean by function inputs and what we mean by function outputs? See nods. I like nods. More nods. Actually, the thing I like even more, well, I don't like, but the thing I want to know even more than nods is anybody sitting there going, I don't know, I don't get it? Awesome. Okay, so hopefully you've all still got your OneBox page open on your machines. I've been talking for a very long time now, so it's time for you to use all you have just learnt about what functions are and what they do and how you write them. Because I want you to write a function called Hello CPP London Uni. How many input values does this function take? None. How many output values does this function return? None, because its return type is void. Excellent. So this is an example of one of these really strange functions that takes no input and gives no output. But But in fact, what I want you to do inside this function is to print the string hello C++ London Uni. And then I want you to call this function from your main. Okay, so have a go at this, and we'll see where we get. And if you have any problems, just raise your hand and I'll come along, or Ollie or Tom. Oh, were you not here for the earlier? Oh, okay. So just go to WAND box. WAND box, yes. So that's just that type of box. So we had an exercise before that was just like writing a hello world, but pretty much looks the same. So you can just use that.
Yeah, but don't I want to be a main? The one where you, because it's call this function for your main.
Well, that's not really what I asked you to do. I mean, yes, they have to.
No, let's write it and we can always cut and paste it to other bits. We can always move it around the sentence. At the moment, I'm just thinking about typing out of it.
So I want you to do that. Exactly what you were asking. I want you to do that inside the brackets.
Then,
If anybody would like some stickers for C++ London Uni, feel free.
okay, so we need console out. Standard something console out, right? Somewhere. Yeah.
That's your output.
So should we copy this?
So your output's going to be LMC.
Yeah, let's copy this and then change it. You're inside main.
No, okay.
Yes. So the function should be outside main. Yeah.
Well, it's done.
Otherwise you like building inside.
Sorry?
Okay. And the reason for that is to basically make sure that
Oh, no, I've had one look
so you can
I'll be alright. I'll get through it. Just you might have noticed I just started rubbing my eyes because like the board was going all wiggly, but I got through it. Be alright.
along with the uni, so the line number 3 and then the line 3. Yeah, you need to open the block of code. Yeah, and then the end of the line here, so that's an easy mistake, and lots of people make that. Make sure that towards the end of the line, have the semicolon, except the line 3, because that's the name, yes, and we start with the block.
Yeah.
And like into main doesn't have that one as well. So this one will have at least, so if you put the text at the end, you will have as well the semicolon. Okay. I know it's a lot, it's beginning to.
Yeah.
Call this from the main function, so we need to do, forget about something. Semicolon, yes. Now you just basically the hello underscore CPP underscore London underscore uni. That's the name. So now you need to say in the main, you want to basically call that. So you need to retype the name. Okay. And now this one, and plus the bracket as well. Yes, because that's the function. So you need to say to the compiler, I'm calling that function. Yes, it's not a variable, it's a function. Do we use this main or do we create a new main? It's only one main. You can't have two mains. Inside the curly bracket, anywhere between 7, yes. Now we have to go back. Yeah. Anywhere in there. Yeah. And what you put at the end of the line? Yes. Try that.
I'm not sure if you can control
So the function needs to be outside of length, it needs to be above name, just below the
the return value is here.
You can't put a function inside of it.
First word.
In a return right here, it makes a difference, right?
Yep. Yep. This is
Main is a function.
so you don't set any argument.
Hello CQP
The void means you're not sending anything. So it's like I send something to the room, but I don't expect anything to hear back. You would say
so main has a return type.
So you say I'm sending inside the room something, and I expect to get a number back. Yeah, in this case we just think of the stuff which will come out on the screen. It is coming out on the screen that's inside the room. Think of the function it's a room. Yeah, so this is the main room, and then we have let's say a small room there, which is called Hello CPP London, and they got screen. So if this cout will be displayed there, you don't necessarily see that. I mean, in our case, because on the console, so you
Take the arguments for this exercise, just empty, but you could. It's where you could
yes.
And then we also need to enter the scope of the function as we do for main.
So use this function.
Yes. Yes.
So the function, so every function has a body, right? Main.
That's another. So it will display another word. Yes. You can put the comment, yes, or you can delete the line entirely. It's up to you.
So what is the difference between that and
Don't change main.
Yeah, but we're doing both things, aren't we?
instead of writing it in
We're going to say hello, that's plus on the new, and we say hello.
No, you need to create one separate. What do you do?
I mean, you can play with nothing wrong, or you can see. It's not printing, it should print. Because click on the delete on the axis. So see the axis? So that will close those when it goes. Okay, and now try and run.
Pretend everything below line 7. Pretend it exists. So you can look at this as an example.
This function is just a line. I mean, you can delete it, so it will have the left.
Main is just every function is equals plus the same syntax. It follows the same format. So it has a return type, it has a name, so you have a return type for a name list, it has a parameter list, and then it has a body, which is instructions of X. Which you don't have with this one.
That's the name of the function. You haven't told what the function
Yeah, no, because it's got console out. So usually in main, you can just say time allows. So print this line. We'll just make it more complicated to show how you
Write your
add in
hello sequence, and then you print it to the console, which is achieved by using cout.
Is that you have to put
You have to put that in.
Why are you on
Then you close the body of the right. So now we'll get rid of white line
Everything correct.
and instead of that, it's going to
Compiler. So the compiler will like, I'm not here.
no, No, you need to make it. So at the moment, you've created a function, right? That function exists, but you're not using it. Main should now utilise the function.
That's just for the.
Here we go. Do you want to try now? Start the new session
You just put its name in and then
try to do it on your own.
you just do some empty brackets. So in the body of that, those two empty lines there. You now call OCP number.
And you do that.
Now you put the name of the function, which is
Sorry, what is that?
hello CP.
Oh, this is a historically, you know, a time ago, they had like a really long, ugly string, which I don't even understand. Tristan and Ollie will know it very well. But the simplification was like, this is a function, it's a room, yes, it's only one room, it's a main room, and everything that happens in the program is happening in this room, it's called. So it doesn't accept it. Actually, in some of the cases you could put some kind of argument inside.
So if you look at how main
yeah, it's a function, yeah? It's not a variable. Otherwise, if you put int main, let's say equal 5, so that would mean there's a variable, a box called main, which is, it will contain number and then value 5. Adding the square brackets, yes, you say it's a room, it's not a box.
Right.
Yes.
So that was the start to get going. So what do you notice about int main? Right, it returns its name is main. It takes an argument.
Yes.
In your case, on line 3,
You see again the square the round brackets, yes.
the name is how
Yes, we call
and
a
it doesn't
room,
take
yes,
the
we call a function called
Open function, next curly brackets tells you what you want to do.
Yes.
This is what you do, close the function, open
correct.
another function, in between curly brackets.
Yes. For example, Python doesn't use the braces, which is tried and later it's confusing. Like, this way I see where the code starts and the block ends. Python would have to have that one a bit higher, and you see how it's then the code, and to me it's extremely confusing. Here is extremely clear. You know where it starts, and the way you and it's just
what's on line 6, right? What's on line 6? Right. What comes after line 3?
I would say open new tab, open new one box, and try taking it over.
The main function has curly braces starting its body. Your function has nothing. That's different. That's why it's exactly the same. They're separate, completely separate. So they have no relation to each other, right? So, okay, they have nothing to do with each other. So just think about, think below line 5 is so separate for now, yeah. Cool. So just focus on everything above line 5. You can refer to it as an example, pretend that it's saying it's not doing it right. So after main, after yours, you have nothing.
You can do it well in a different way. I'm not sure if you can cover this. You can declare the function, declare the function,
which is delineated by the curly braces.
Yeah, so basically, you have the same amount of screen. They are very complicated. So what we could do this.
Make it the same, do the same, follow the same logic.
So basically, if you don't want for whatever reason, you don't want the function to be at the top. Yes. Now, if I would run it, it will give me an error.
Get back.
Where's the what you're doing? Yes.
So now you.
So what's the workaround? So
Yeah, if you want to do it on the
first
same
line.
line, you can. So it might be a bit nicer. It might look a bit
What we call this in C++ is like you making a promise. I promise you, because the compiler goes from the top, from line 1 to the line 17. And we say, when it gets to number 4, yes, it says, I promise you there is a function which returns nothing, it's called hello, doesn't take an argument, somewhere there different. And they say, that's fine, I take your word for it, yes? So I put the semicolon, and now I'll just hide this, yes, I put a comment. Yes, so this is a line comment. Yes. So now this is text rubbish. Doesn't have to exist. So you
Yes.
click it, and you can see
Sorry, we're-
these like, whoa, yeah. Undefined reference to hello. So what the compiler says, you are not a very nice person. You promised me there will be hello, and there isn't. I couldn't find it. So
There are ways of doing it, but this is
so
exactly
now I
what I
said,
was
sorry.
Yeah, this exactly matches
Yeah.
what I was
So I uncommented that, and I run. And it says what it does, yeah? So
now,
Well, I have mentioned that main should return
went there, so like I need to find this hello. So we look forward,
Well,
so, oh I got it. And
Did I leave it off?
executed
I
what
tried
was
to make
here,
sure that I
yes.
actually did it.
And then
So I mentioned
once
there are
we
some
got
questions.
this line here,
Main is very special.
here,
One of the ways
and
to
then
tell the
set
special
return
is that
zero.
tell the computer
So
you
the
want to run
for main and only for main you can unmix this
It was like a
return.
famous joke, you know, like I hope
Because that's sort of
I hope my
like
children
one of those things
will
to
return
remember.
zeros
Sometimes look
to
at that
their
and go,
right.
oh, my function returns zero. I don't have to write it down. What you do is every other function you take right.
Here we go.
So I tend to, just to avoid that whole like having to remember that magic rule. Yeah. So in fact, that's absolutely
feed
correct and will do the right thing. You could put that return zero at the end of main.
which basically is printed. So this says, so this is standard function print. What am I going to print? I'm going to print this thing over here because the arrow is pointing to the feed.
in the later stage of calls, like, you know,
Okay, ladies and gentlemen, we are now indeed a little over time, which is a shame because I sense people were really having fun with that, right? No, it was really cool. A lot of people got to doing it or got very close. So very well done to everybody who did. For those who didn't, very quickly, this was my solution. So we define this function, hello CPP London Uni, takes no input, doesn't return anything, and then we're taking our string and streaming it to our console output. Then in main, we always have to have a main function. Main always has to return an int. We're calling our function, it doesn't take any input parameters, so we give it no input. Doesn't have a return value that we have to worry about. So all this does is execute this function, and then we return 0 from main because that means that our program ran successfully. Hold that camera because you're going to need it in a few seconds.
Oh, no, I just need to check my work.
So yeah.
Is it also because we've defined main as an integer, therefore it has to return?
It has to return an int. Absolutely, yes. Yes, well done. Right, so come on. Just in case you thought we were finished there, there is a third exercise which you might want to. You're going to have a pretty good zoom on your camera from the back, or you can come up and have a look at this. In fact, what I'll do is I'll put this back on the screen in just a second, and you can maybe take a pic as you walk out. Quickly flick past that. No, don't look at that. Right. So, what have we learned today? Well, we've had a very, very brief kind of whistle-stop introduction to C++, and I have to say this introduction that was used before, in many ways, it's sort of tailored to the audience that we've had before. It's just people who are or know a fair bit about other programming languages. So as an introduction, that was kind of the audience it was tailored to. I didn't really know who we'd have coming tonight, right? So I can appreciate if you are completely new to this stuff that perhaps a lot of the things I talked about tonight, perhaps the terminology I used was a bit like, whoa, what? But don't worry, it will all start to make sense. So we looked at how Hello World works. We talked a lot about types and type safety. And that, if you remember nothing else from tonight, this notion of types is probably the most important one to take away. We learned how to use this hash include thing for standard library headers. That is very important. So we saw that for Iostream. There are various other standard library facilities that we want to make use of. And we learned how to define, how to write our own functions and how to call those functions. And well, if you did by the time you've done the third exercise, you will have been introduced to standard string as well. Oh no, don't want that solution again. So I'll leave you just with this slide. Again, if you want to take a photo of it, if you're going to come on Thursday, then I highly recommend you do. Everybody can have a go at this. I will also, by the time these slides arrive, and if you want to get a head start, I can put it on the screen as well in a minute. There was also a bit more homework that's a bit more in depth than this. It's a bit of a stretch, perhaps a bit more to have a look at. So I'll give you that to work on as well for Thursday. But that's it. Thank you all for coming. I hope I haven't managed to scare too many of you off. Really appreciate it, and thank you again very much to the University of Law for having us. We really, really do appreciate it. Thanks, everybody.
Thanks, everybody. As our tradition, after the class,